Remote sensing is a reliable tool that reduces time, energy, and money drastically in exploration activities by narrowing down the target zones that are conducive for mineralization. The talk will give you knowledge in how remote sensing uses lithology, structure, geomorphology, alteration zone, in delineating zones for future and further exploration. It will introduce you to techniques like principal component analysis, band ratio, minimum noise fraction, and spectral classification in the process. 2 case studies will be presented for more understanding of the participants. Finally, you will get acquainted with the ASTER and hyperspectral data acquisition. I wish you all an excellent learning session, and I am sure that the lecture session will be beneficial for the academia. Let us join together in the effort to build a modern, diverse, and vibrant nation. Best wishes and thank you.
Thank you, sir. Thank you for your kind and encouraging words. Now moving to the technical session, I would like to request Dr. Nisa, Director of Photogeology and Remote Sensing Division, GSA Training Institute, to deliver the talk. Thank you very much.
Thank you very much, sir, for joining our session and addressing our participants. Before that, we will request our participants for one group photograph. Arjit.
Yes, ma'am.
So all the participants are requested to switch on their their video calls so that we can see it.
So participants, kindly switch on your video for a few seconds or say for 1 minute so that we can take a snap.
Done?
1 minute, few seconds more. Yes, ma'am, done.
Thank you, Dr. Ajit Barik, and thank you to our HOD and Head Mission 5, Dr. Matthew Joseph, sir, for sparing his time for this inaugural program. Thank you very much, sir, for joining us. Audience, can you hear me? I'm audible to everyone? So I'll start to share my PPT and we'll start our lecture session. Just please excuse me. Hello? Please tell me. See, you just send an email or you contact some other people. Take care. The number is given because I am conducting this online lecture session. Okay. See, you try again. It's visible to everyone. Geological mapping and mineral exploration by ASTER and hyperspectral remote sensing techniques. So I'll start with this why this remote sensing is important for mineral exploration point of view. As we know that our mineral exploration is, it's a ever evolving science, and as the our civilization progresses, our need is growing, and the population increasing, demand for the mineral resources are also increasing, and it's demanding for more and more search of new deposits which we can use as a human being. So it's challenging for us to utilize new techniques or implement new techniques to identify new and hidden deposits in a shorter period of time. That is the challenge. Okay, so because of that, we are here focusing on remote sensing techniques for mineral exploration point of view or geological mapping. So we can say the need of the hour in mineral exploration is to use the latest technology to discover our mineral deposits in a cost effective and time saving manner, because to search one particular deposit it takes at least 15 and 20 years in a traditional method. So as on date our requirement is there to identify different deposits in a shorter period of time and cost effective also. That is our main concern. So this can be fulfilled by the techniques of remote sensing. So remote sensing technique can help us to locate the area of interest or mineralization of significance with the better accuracy than our other methods. That is the thing. So we can see it here, like with the advancement of multispectral to hyperspectral. That is the advantage with the remote sensing techniques, that from few bands to we are going to maximum number of bands, and it will help us to identify in a different minerals or mapping. We can do the individual minerals mapping by using hyperspectral techniques. So remote sensing is playing a key role in the field of geosciences, especially our mineral exploration. So spectral range like 0.4 to 2.5 micrometer in the remote sensing, it's a crucial wavelength range which are playing the important role for the identification of the surface material. So increased number of spectral channels in visible VNIR, visible to near infrared region, short wave infrared region, that is very useful for us for the mineral mapping. So alteration minerals especially which are associated with some kind of potential zones or mineralization, that is playing its role. And if we have more and more number of spectral bands in VNIR, that is visible to near infrared and short wave infrared, so we can identify each and every minerals from using remote sensing data. As a result of amalgamation of spatially contiguous spectra and hyperspectral remote sensing and spectrally contiguous images, hyperspectral remote sensing is able to map alteration minerals, especially minerals which are associated with certain kind of mineralizations that we can predict or we can identify through the remote sensing minerals, remote sensing techniques.
Excuse me, madam,
Yes.
excuse me, can you raise your volume, please?
My volume is okay, please raise your volume. Can you see, can you hear me properly? Please use a headphone. I am audible to everyone?
Lecture. Yes, ma'am.
Please use your headphone. So you can see it. If you wanted to do some quantitative or qualitative analysis or mapping, this hyperspectral remote sensing is very useful. And this hyperspectral remote sensing is being used since last 3 decades to get the information on mineral. And in India, if we'll talk about the Indian subcontinent, so obviously it's just an initial stage of the investigation, because we have not used remote sensing technique as such what we required actually. So still we are in a initial phase of using hyperspectral remote sensing. So if we'll see special remote sensing techniques, how these techniques are useful for us in mineral mapping, actually we can see over here. There are certain spectrum of wavelength range which are very important for us. As I told you, visible to near infrared and short wave infrared region is there. So if you will see VNIR, 0.4 to 1 is the region which is very crucial for the mapping of iron oxide, if you are focusing for the rare earth elements or transition elements. So more number of bands in this region will help you to identify more and more minerals related to iron oxide, hydroxide, or rare earth elements or transition element. If you focus sphere region, from 1 to 2.5 micrometer is the region, and if you are interested to map ALOH bearing rocks or minerals, or MgOH bearing minerals, or carbonate or sulfate or mica or amphiboles, so sphere region is very important from geosciences point of view. Why it is important? Because mostly alteration related minerals which can be associated with the mineralization, that is here in like AOH, MgOH, or sulfate or carbonates, that is associated with some kind of alteration. That's why we are focusing in VNIR and sphere of a spectrum of remote sensing region. I hope I'm not very fast to you. So you can see it here how many factors are there or through which our mineralization is basically controlled. If you'll see, we have two types of different deposits. One is primary kind of, second is your secondary type. So if you are talking about the primary kind of mineralization, basically that is controlled by lithology, structure, or alteration. If you are thinking about the secondary type, or some mineralizations are reported or controlled by the geomorphological features, as well as geobotanical indicators are also there, which are required to identify through the remote sensing techniques. So you can see it, remote sensing, how it is playing a role, or what is the significance of remote sensing in mineral exploration actually. If we'll see it here, there are certain indicators or indicators for the mineralization actually. If you know that indicators are basically guiding us that there are some potential zones or there are certain mineralization zones which can be proved one deposit for us actually. And if we are able to identify those indicators or guides through remote sensing data, definitely we can locate one potential zone for the mineralization. So basically remote sensing, how it is helping us, you can see satellite data, what we can do actually. There are three things which we can draw from the satellite imagery actually. One is your mapping analysis of regional and local fracture system that controls ore deposits, because this mapping of the structure is very important. This structure is basically working as a weaker plane for any kind of mineralization. So that is our one focus. Second thing is that it provides basic data for geological mapping. Again, we have the regional scale satellite imagery. So your geology, how it is expanding or what is the extension of geological feature, that can be seen through the satellite imagery. And third, detection of surface alteration effects that is associated with ore deposits, or if we can recognize hydrothermal altered rocks through their spectral curve, that is very important to identify. So through remote sensing data, these three things we can do using different satellite imagery, especially in a multispectral, we can say ASTER, and hyperspectral also, because so many bands are there in hyperspectral imagery. So how why this remote sensing is useful for us, and what is the advantage of remote sensing actually? Because through remote sensing data, wide range of main advantage of remote sensing technique is that accessibility in regional scale. Another is we can save our time and money by using remote sensing techniques, and nowadays it's a major component of any studies. Actually, preliminary studies we can do through remote sensing data itself. And it acts as a tool for targeting concealed deposits by integrated studies and to narrow down the field surveys to a smaller area. Our objective is that from regional scale to smaller scale we can come and we can target the potential area for the mitigation point of view. And known drill results can be integrated with the topographic maps, structural maps, and ore grade if it is present with us. So that can be also integrated with the remote sensing data. That is the advantage with the remote sensing techniques. And data synthesis can greatly increase the accuracy and effectiveness of any exploration program if we are using along with the remote sensing techniques. And it works as it acts as a tool for targeting concealed deposits by integrated study. That is our objective, to identify the area in which we are interested actually. And expensive operations like your drilling and field work and other things can come after the identification of the potential area first through the remote sensing and integrated methods, and then we can identify that particular area, and drilling or other things we can plan afterwards. So if you will see the role of remote sensing in the different stages of exploration, we know there are 4 stages in mineral exploration. From G4 to G1 is the stage, and if you see the G4, basically it's a regional scale, your reconnaissance and regional overview, we call it G4. So basically here our objective is to reduce the area, means we are working on a systematic mapping on 1:50,000 scale. Next stage here, preliminary investigation, where we call it G3, and we are basically taking a smaller area. Normally scale is 25,000 or 10,000 scale. And remote sensing is playing from regional to different level of exploration also. We are using remote sensing techniques. Detailed surface and general exploration G2, very small area, we want detailed information on 5,000 scale or 4,000 scale. And here high resolution data can be used to refine with the refined or new techniques of remote sensing techniques. We can utilize remote sensing techniques, different techniques, to further refine our area or further narrow down the area in a G2 scale also. And detailed subsurface exploration is the advanced exploration stage or G1 stage. So if you see in overall 4 stages, G4, G3, G2, up to G2 we have to use remote sensing because it's a very useful, it help you to plan many things actually. And if you see, if different stages of mining is there, in different stages of mining, if you see it here, we are seeing basically 3 stages are there in mining. One is your geological exploration. Again, remote sensing is playing its role. Regional mapping of lineaments or deformed zones along which minerals are concentrated. Second is your advanced stage, where we are trying to identify the actual width or actual extension of any ore body. So this remote sensing technique is again useful for the mining stage also. Third stage is your mining. If it's everything is proved, so mining stage is there, especially in a case of open cast mining. So monitoring is very important, and that is also possible through the remote sensing. Like nowadays we are talking about a drone technology. Drone technology is nothing but a remote sensing, and for the monitoring purpose or geo-environmental purpose we are utilizing remote sensing technique itself. Please switch your mute yourself. नायक सबको म्यूट कर दो.
Mining stage. So then close mining and the rebuild close.
All are requested, please mute yourself. So why we are thinking about the ASTER data to utilize in mineral exploration or geological mapping. As on date, if you see ASTER data is having different level of data actually. If you see it from 50-meter resolution to 90-meter resolution, and it's covering wide spectrum from visible to near infrared and thermal range of regions band, and it is very useful for the geosciences application point of view. It is basically used to create detailed maps of land surface temperature, emissivity, reflectance and elevation, and the swath of ASTER data is almost 60 kilometer if you see it. So here we can see, if you see the table, what is happening. We have the three systems in ASTER data: VNIR, visible to near infrared region, and shortwave infrared region and thermal region. As I told you, VNIR sphere is very important, and as well as thermal also very useful for geosciences application point of view. And you can see it here, so many bands in a shortwave infrared region. If you focus, we have 6 bands in shortwave infrared region, and whatever alteration minerals or the minerals which are associated with certain kind of alteration zones, that is falling in this region only. So that's why this ASTER is very useful for us. And if you see thermal region, again, if you want to map silica rich rocks, or if you want to map silicate bearing silicate rocks, or your carbonate or phosphate, so we have to focus on thermal. So as on date, no other satellite imagery is there which is having this much of bands in your shortwave infrared and thermal. That's why we are maximum time we are focusing on ASTER data to utilize for the geosciences point of view, geological mapping actually. And if we go to the hyperspectral, what is the advantage with the hyperspectral actually? It's a covering entire spectrum from 0.4 to 2.5 micrometer range, and bands are very narrow band and contiguous, and from VNIR to sphere, total spectrum that your sensor is covering to provide the satellite imagery, and normally it is having more than 100 bands. What we have seen in ASTER data, only 14 bands are there in a multispectral, but once we are talking about the hyperspectral, it is having more than 100 bands, and the bandwidth is from 5 to 10 nanometer only. So very each and every detail can be seen through the hyperspectral imagery actually. And not only that, it collects data in a data cube, and spatial information we can get in a X and Y plane, and spectral information. Spectral information means we can get the wavelength information in Z direction actually. That is the advantage. So here we can see how multispectral, very broad band data we have, and hyperspectral, very narrow band. And we are getting so many bands in hyperspectral, whereas in a multispectral we are getting few bands. So you can see it here, like how that band or data cube is there, and image analysis as well as spectral analysis is possible from hyperspectral remote sensing actually. And if you see it here, as I told you, because hyperspectral data is having the spatial information and spectral information both, so here each and every pixel we can get the spectral information also. That is useful, and we can identify individual minerals or object one by one. So it gives you information of spatial as well as spectral from every pixel of the image. That is the advantage with the hyperspectral remote sensing. And these spectral signatures, based on that we can discriminate individual minerals, and how, because of the absorption features of each and every object is different for every object. That's why we can identify each and every object on the Earth's surface using spectral signature or spectral curve. So actual detection of material is basically dependent on certain parameters actually once we are using hyperspectral remote sensing. And you can see it here, those parameters are that factor is your spectral coverage. Spectral coverage means 0.4 to 2.5 micrometer, we are getting very narrow bands, so we are getting maximum information about the spectral curve. So, accordingly we are seeing this spectral resolution also. 5 to 10 nanometer is the bandwidth actually, and signal to noise ratio of the sensor, abundance of that particular material if we are interested, like if we are interested for the carbonate or we are interested for phyllosilicates. So abundance of that material is also important. And next is your strength of absorption feature, how much it is absorbed. So absorption feature is also very important or crucial for the identification of each and everything in a particular pixel from hyperspectral imagery. So what is the application of hyperspectral image sensing? We are talking about mineral expression point of view. So basically hyperspectral remote sensing is enabling us to accurate identification of both target as well as the phenomena, as the spectral information is presented on a spatial rather than the point. Here we are getting one spectral curve that rather than one point actually. That is the beauty of this hyperspectral remote sensing. Not only that, it provides a new capabilities to quantitatively assess chemical and physical aspect of the pixel which is in question, where we are interested actually. And this is a tool with many applications, and nowadays hyperspectral is useful or being utilized since long time, and it's having so many applications. If you'll see, like in geology we'll talk, it's a mineral with soil types, all those things can be seen. Coastal water like chlorophyll, phytoplankton, organic materials, suspended materials, all those things are being used to identify these things by hyperspectral remote sensing. Atmosphere in like water vapor or cloud properties, this hyperspectrally used. Commercial what we can say, mineral exploration especially it is being useful. Agriculture point of view, forest and others. Similarly, we are using it for the geomorphological point of view and forensic science also. So there is n number of application of hyperspectral remote sensing in n number of field actually. So we are basically concentrated in a our geosciences point of view or geological mapping and mineral exploration point of view. So what is the difference and what is the advantage with the hyperspectral and ASTER data? See, ASTER data we have maximum band in sphere as well as thermal also. Hyperspectral is having the bands especially from sphere VNIR to continuously sphere region. And if we'll see, if we'll compare, hyperspectral data is basically useful to delineate variety of minerals. Individuals can be identified by using hyperspectral data, which our broadband or low resolution sensors like multispectral sensor which are unable to identify each and every. Broadly we can classify this is phyllosilicate, this is carbonate, but in carbonate what kind of carbonate we are able to see, that is only possible through the hyperspectral remote sensing. And many surface informations can be derived more accurately within hyperspectral data actually, and use of hyperspectral sensor is still relatively costly and queries professional manpower to operate the instrument and process the data. Actually, if you don't have the idea about the hyperspectral concept or remote sensing, so obviously it is a really challenging task for you how to interpret to how to get the information about the data. So here we can see some graph I have shown it here. What is the difference in a multispectral or there are only few bands, like ASTER is only 14 band only. The moment we are going hyperspectral, it's a covering 0.4 to 2.5 micrometer region, and we have more than 100 bands. Obviously, we are going to get maximum information in hyperspectral, and here spectral curve is also given. So, in a sphere region, 2 to 2.5 region, if you see broadly, we can say this is this mineral, but in a hyperspectral case, each and every mineral can be identified based on the spectral curve or absorption. That is the advantage with the hyperspectral rather than the multispectral data. So here I am just showing the major differences in ASTER data as well as hyperspectral data. If you see the number of bands, so number of bands in ASTER is 14 and in hyperspectral is more than 100 bands. Wavelength in ASTER case it's a discrete kind of, whereas in hyperspectral it's a contiguous. And bandwidth also you can see in ASTER data is 80 to 100 nanometer, whereas your hyperspectral 5 to 10 nanometer. So accordingly we are getting, and swath is also one point. ASTER data is having 60 kilometer, whereas hyperspectral data whatever as on date is available, band swath is very poor actually, 7.5 kilometer or like that. So it's a very small area, or 20 kilometers only width is there. So it's a very small area it's a covering. But yes, it is very useful basically. And obviously if we'll go by the cost, so if we'll talk about the ASTER is nowadays cost of free, it's a cost effective, or it's a free of cost, available in the public domain. But hyperspectral data, again it's expensive, because we don't have the data for the entire country, or continuous data sets are not available with us. So obviously if we want something, maybe some plan or something we have to do, so obviously it's a expensive affair for us. So if we'll see the processing techniques, how we can utilize these techniques, and useful for us for identification of different features. In a multispectral, normally what we are doing, first step is like a false color composite. Different composites are very useful, and band ratio technique is very useful. Principal component analysis and classification, especially your classification, supervised classification is useful for us. And if you see the hyperspectral data here, reflectance data basically we are using, and the techniques which are like minimum noise fraction is there, or ND visualizer, and classification methods are there, that is very useful. So we can set here like processing techniques like band ratio technique. It's a very useful and effective methods to identify the individual minerals. So if you are using ASTER data, broad idea about the mineralization, but if you are using hyperspectral techniques or hyperspectral data, so accurate analysis we are doing for the particular mineral actually. Similarly, your principal component analysis, basically it is mathematical things we are running, and we are just trying to increase the information and segregating the noise from the data actually, principal component analysis, and the input the output is more interpretable than your original imagery. So it will give you a better idea, better picture of your area. Similarly, if you see MNF, it's again very useful technique. It's similar to our PCA, and here basically we are again what we are doing here, we are segregating noise from the data actually. The moment we are segregating the noise from the data, your image quality will increase, or that will be more interpretable than the original imagery. So these are the techniques, and other technique is your spectral classification. Spectral classification based on the spectral signatures from image, or spectral library, or spectral signature which we are collecting from the field, or from the images. We can utilize those inputs to identify the particular object in the satellite imagery. That is very effective, and very popular methods are also there for the abundance mapping of minerals actually. So it serves to identify various minerals and map their spatial distribution in the imagery, and that is the advantage. We wanted to know the particular minerals location in the large area actually. So these methods are helpful for us to identify those locations actually. And there are many methods actually. If you see popular methods of classification techniques, so spectral angle mapper is there, your constant energy minimization is there, your adaptive coherent estimator is there. So many methods are actually there which are useful for us for mapping of minerals actually. So if you see, or if you go through the ASTER or hyperspectral imagery, how we are utilizing, so some example I will show you how it is useful for us. So lithological mapping is why it is important, because mineral resources are the product of geological process, and the exploitation strategy is governed by the geological factors and environment in which these deposits occur actually. And lithological sections help us in visualizing spatial, three-dimensional and geological relation. That is very much important from the mineral investigation point of view. So there are certain minerals actually, or certain kind of deposits are there which are having some preferences of lithology or host rock actually. If you see like carbonatite or volcanic flow or metaphylites, these are having some specific or preference is given for some certain kind of host rock actually. Similarly, if you see like BIF and coal, it's a syngentic sedimentary deposits, and it's a preference actually. We know this will happen with this only. It's a preference actually, geologically preference. So remote sensing basically it is used to prepare geological maps and obtain the basic geological information for further detailed work actually, and we can utilize it in a better way. And here I just you can see it here what I tried to show you, that geological map is there, but how this remote sensing data is useful for us to identify the extent or lithological control or lithology extension, other things we can utilize these remote sensing techniques. So here whatever I have marked in the box, that is the difference in a geological map and the after mapping through the ASTER data, what are the changes we can see. So we can update our geological map and we can know the actual extension of the geology or lithology, we can say. Here also it's a part of Karnataka only. So you can see it here, we have control over here, and different lithologies are highlighted very nicely actually. So like here also you can see, or clear cut boundary we can demarcate by using remote sensing technique. That is the advantage. So here also some example from hyperspectral as well as ASTER data is given, and you can see the changes, how this lithological mapping can be done. Whatever is not visible in ASTER data, because we don't have that much of sufficient bands. So in a ASTER data, hyperspectral data, that is much more visible than the ASTER data. So more and more details we can find in the Hyperion or hyperspectral data here. I have used Hyperion only. So here also again ASTER data and hyperspectral data for the same area, same location, and how variations we can monitor through the hyperspectral data actually. Structural mapping is another important topic. So I hope I am audible to everyone. I am audible? Okay, fine. I hope I am not going very fast also. Okay. See, next important thing is your structural mapping actually. Structural mapping, it's important. Thank you everyone. I got your response. So structural mapping means structural geology plays an important role in mineral and hydrocarbon exploration actually, and can indicate potential location for mineral deposits. That is our focus actually. So within a mineral provinces, numerous fractures or fracture intersections are good prospecting targets actually, and because fractures are channels for ore forming solution. Why? Because these fractures or these structures are the weaker plane. Along with that, some fluid or some brine from the magma chamber can try to come on the surface of the earth, and the moment it is trying to come on the surface of the earth, there are chances that it will bring some kind of metal or some kind of deposit along with that. So because of that only this fracture or structure is important in a geological point of view. So structures like your fault controls fluid movement in the shallower to deep level and to sides of rocks that may have accumulated or deposit actually. So through remote sensing data, it is much easier to map the structures than going in the field and mapping it, because it's a very time consuming process, and it is going to take years and years to map the area actually if you want to map the structures. But through remote sensing data, it's a very easy and faster way you can map the structures. So basically information regarding location of mineral deposits by certain types of geological structures, structural belts actually, like your shear zones or fault or fracture, contacts or fold or joint intersections of some specific structural features can be obtained from the satellite imagery actually, and and vital for the planning exploration strategy. So you can see so we can go for the 5 minutes break. Exactly 5 minutes will start. Once again, welcome to all. I am audible to everyone? We'll start. Thank you for your responses. Fine. So, structural mapping, you can see it here. Thank you very much, participants. So you can see it here, like one example I have given how much this structural informations we can see. This is the ASTER data which I have utilized for my study, and each and every structural informations we are able to see it here. Similarly, you can see it here, like ASTER DEM I have used, and from DEM where are the exposures, how it is going, and I tried to extract the information like your drainage and lineament informations, which are very useful for our mineral exploration point of view. So structural mapping is very much crucial and important. Like here also you can see this is the extra data of Ajmer area, where structural informations and everything is visible to us, and you can see how this fold is there, and certain new informations or exposures we can able to see how my cursor is moving and all. We can see it here. We can map such kind of information, structural information, like here whatever folds are there, we are able to see those structural information and contact also. Similarly, again it's a DEM data only, and structural mapping is very much crucial. So more structures or more number of structures are or linear features are present, or it's a crisscrossing area. So so you can see it is very important from mineralization point of view. And similarly, you can see the fault, how this movement is there. So fault is easily identifiable in the satellite imagery. Here you can see how this linearity we can see it's a part of Chitradurga schist belt, and this linearity is very much visible in the satellite imagery actually. And next important thing, lithology, structure and alteration. Actually, alteration zone mapping is very important for us again. And why this is important? Because it acts as a tool for mineral exploration. How? Because the hydrothermal alteration can affect large volume of rock, and if recognized and correctly interpreted, it may provide with a great or with a larger target that the ore body we seek actually. Means it's a tool to identify the potential zones for the mineralization point of view. And if we are able to identify alteration zones or alteration minerals correctly, definitely we can locate one potential zone for the mineral exploration point of view. So it's just a tool, or it's a guide for the ore deposit actually. So through remote sensing data, we cannot identify the alteration zones, but the minerals which are associated with some alteration zones we can identify, and especially through the hyperspectral data. From ASTER data we can identify broadly it's a amphibole group of minerals, or it's a carbonate group of minerals, or it's a clay group of minerals. All those things we can identify, but in that which mineral is that is little difficult for us. But through hyperspectral data we can utilize our individual minerals actually. So individual mineral mapping is possible from hyperspectral data. And oxidation is another important thing, because if oxidized zones are there, there are possibilities that we are just able to mineralized zone. So oxidation, silicification and silication is also one of the part of area or in which we are interested to map actually through remote sensing techniques, and it's easy to identify through remote sensing techniques if you have sufficient number of bands are available in that particular zone of electromagnetic radiation. So again, this is one example of alteration zone mapping, and this is again you can see it here just through MNF we tried it to identify certain area, and we visited to the field also, and we came to know that it's a gold working actually, and on a surface carbonates and iron leaching is there actually, or iron alterations we can say. So such kind of things we are able to identify it from the remote sensing techniques. Similarly, again it's a part of Karnataka only, individual minerals I was just trying to identify whether I'm able to identify or not. Here we got three types of alteration actually. One is chloride, another is iron, and third is your carbonate. So in an area we visited also. So here VIF is there, and carbonate veins are there in metabasalt actually. So whatever you are seeing here white color is basically it's a carbonate veins which are intruded in a metabasalt. So in a Karnataka we know that carbonated metabasalts are quartz vein or carbonate veins, that is very important, and along with the metabasalt actually to host the gold mineralization actually. Similarly, again it's a part of Karnataka only, and band issue technique I just try to utilize and trying to identify the potential zones by ASTER mapping actually. So here again some alteration zones or potential zones are highlighted in a different colors actually. And here also all these are already published. If you want you can refer it through academia or through ResearchGate. So again other band combination of band issue I just tried it, and again some alteration zones are highlighted from the ASTER data actually. And this is again from the Karnataka only, it's a part of Chitradurga assessment belt, and individual minerals I was just trying to identify whether I am able to locate it or not. So different alteration minerals we were able to target from remote sensing techniques. And this is a very NG data where I just tried to use MNF concept or MNF method to highlight the area which is mineralization point of view important. So here you can see different areas are highlighted, and those areas are very crucial from the mineralization point of view. So this technique is also a very useful technique for alteration zone mapping. Similarly here some classification method I tried on a very NG data actually, and by using this different minerals which can be associated with certain kind of alterations, I was just trying to compare different classification methods, and I use it, and we got very good result, and we verified it also in the field. So next is important thing is geomorphological features for the mineralization point of view actually. See, understanding information related to geomorphic features and development of topography is very essential, and in search for mineral deposits 3 points may serve for geomorphic features. These are your some minerals have direct topographic expression for its deposit actually. Next is your geological structure and topography of an area have correlation with clue the accumulation of mineral. Okay, and third is your mineral deposits like iron oxide, iron ore or bauxite, chromite, copper, limestone, magnesite. All are exposed to the surface and easy to explore. And here geomorphological features are very important. And secondary type of deposits like your placer or diamond or monazite kind of things, that is again associated with some geomorphological features. So if you see a placer deposit, basically their preferences are like, or their occurrences are near to your buried channel or abundant meander scars are very crucial locations for the placer deposits. So through remote sensing data we can identify those locations actually. And like a deposit formed by the process of residual and supergene enrichment, that can be also indicated by the geomorphological features like your hills, ridges, plateau and valleys. That is very important for us. So just for your understanding, from different satellite imagery or two different years of satellite imagery was used to identify the shifting or change in the course of the river. So that was successfully done through remote sensing data, and different geomorphological features like valley fills or pigment or alluvial plains we tried to identify, and successfully through remote sensing data it was mapped. Here also, like we know that so kimberlite is very important, and especially structures are playing, or geomorphological features are also very crucial in identification of the kimberlite body. So I just tried to identify some circular features from the satellite imagery, and just I tried to verify it with the existing informations which we have already. So what we found that the circular features or the features or geomorphic features which we were able to identify from the satellite imagery is near to the reported kimberlite bodies actually. So this is the advantage of geomorphological feature. Geoportical indicators are also very important in mineral exploration point of view actually. In India, I can say that so far we have not done that much of a study, or it's not very popular method, but it's very useful actually, and R&D kind of thing can be done actually. So why these geobotanical indicators are important actually? If you'll see, your vegetation is basically influenced by the mineralization, lithology, or rock fracturing. Whatever rocks are there, or composition of rock is there, your vegetation is growing as per that composition of the rock or your soil. And reflectance spectra of foliage. Reflectance spectra means a spectral signature of the vegetation which is growing over the mineralized area may differ from the spectra of the foliage in adjacent non-mineralized area. Means the area which is having the mineralized zone and the area which is not having any mineralization, the foliage spectral curve will be different. Why? Because the composition variation of the rock is going to affect the health of the vegetation. So that can be reflected in the vegetation also. So site with the high concentration of old mine tailings for lead or zinc and copper or zinc and other your metals may develop unique flora because condition is toxic for most species. So everything cannot grow over there. So certain specific things will develop there. So if we'll see three or what is the major role of geobotanical criteria, or how we can identify our geobotanical indicators actually. So one is your lack of vegetation. If because of some reasons, if there is some lack of vegetation, so that is one parameter or one criteria. Indicator species like certain kind of outcrops may and soil enriched in a certain elements actually. So certain specific species will develop over there actually, or it will grow only. Like some researchers they have done, this is not my work, they, as per their observation in a Malanjkhand area, in a soil which is having the copper value, that jungli tulsi is growing, and at the same time the nearby area where there is no copper present in the soil, no jungli tulsi is like that. So this is the observation which was made by some researcher, and they have published that paper also. It's in 2004 it was already published. And third is your physiological changes, like your high metal concentration in the soil may cause abnormal spectral reflectance characteristics. Suppose one healthy vegetation is growing, one crop is very nicely and it's coming very properly, then sudden changes or health is affected by certain kind of high metals. So that changes we can monitor through the spectral studies. So like some of the research or reports are there which indicates that there are certain preferences are there, like here blue flat mint is developed wherever copper is there. So it's a photograph, or it's related to your Congo, Republic of Congo, where copper is more. So this blue colored flat mint is developing in that area. Similarly, as it's just for the representation point of view, that jungli tulsi or spectral curve, how it is changing actually. If a healthy vegetation is there, a curve like green color will be there, healthy vegetation. If it's like certain changes or some effect is there because of the presence of some heavy metal or toxic thing, definitely health of this vegetation will affected. So maybe it will changing the its characters also. So that can be identified from the spectral studies. So ultimately, what is our objective actually? Why we are using hyperspectral and ASTER data for geological mapping? So what we have seen, we can do the geological mapping, structural mapping, alteration mapping using ASTER as well as hyperspectral. Next is mineral exploration. How we are utilizing this these two techniques for identification of potential zones. So our objective is to identification of the potential zones and further narrow down the area so that we can concentrate in that particular area for the mineral investigation and anything, any deposit is there or not. That is our main objective. So I'll just show you some of the example from two different locations. One is from the Rajasthan and another is from the Karnataka. So I was working over there for the base metal. So you can see remote sensing data information, alteration, structural information, drainage information, and as well as whatever informations are available with us, we have integrated. As I told you, if you are integrating remote sensing data with the existing geochemical, geophysical or drilling data, or if you have the drill information, So if you are including all the information along with your remote sensing data, so accuracy level is more and more. And if you are going to further in a field verifying it, so 100% your accuracy level is more and more than anything. So it will help you to reduce the area, and it will help you to focus on particular or small area for the detailed investigation. So you can see so many potential area we have integrated. We used the geophysical, geochemical data and other existing information of GSI, and along with that our field inspections were there. So what we found, these two areas are very good, and the oxidized zone totally we can say, or gossenized zone, and full of malachite actually. So from larger area to smaller area we have come, and we have focused in particular area. Similarly, you can see it here, like this is again from the Bhilwara area, Rajasthan. We were working here also, and from a large area we have identified certain potential zones with the field validation, and we have suggested this area for the detailed investigation by our WR region. And in 2020-21 this block has gone for the auctioning also. So how through remote sensing we have narrowed down the area, and we found that this area is potential area for the detailed investigation. Similarly, this area is again from the Rajasthan, and again base metal only, and we tried to work here. We identify the potential zones. We have selected that block for the field investigation and certain chemical analysis also. So what we are seeing here in a photograph, your rock with the malachite stain, we can see oxidized zones we are able to see, and propylitic alterations also we are able to see. Carbonate is present, epidote is present, and chlorite is present along with the malachite. So and chemical analysis of this sample also, it is showing value of the copper. So like that we are narrow down our search area, and our focus is particular area only instead of in a large scale. So from larger to smaller area we have come, and again this is the part of our Chitradurga assessment. And here, as I told, geological informations also I was showing you, okay, how this is means width wise this area is more, and this area is also more actually. So it's a tapering, and here we have your metabasalt and carbonate veins are there. So we have identified this, and again spectral analysis we have done, and gold analysis was also done. So again gold analysis we got some value of the gold. It's a 30 ppb, and it's very poor actually, 44 ppb, but yes there is indication of gold mineralization in this. So our focus will be again this detailed investigation of this particular block actually. So similarly it's from the Gadag, again it's already published one. So structural alteration, all the controls we tried to identify, and we found, and so already known area actually, and lots of work has been done for the gold investigation point of view. So here we were trying that structural control, alteration control, as well as where is the gold location is there. So accordingly we have distributed gold occurrence 0 to 55 meters, or 50 meter, 50 to 100 meter, 100 to 150 meters, like that some buffer zone we have created. And we found that our majority of the alterations along with the lineament or structural control is occurring along with the gold mineralization, which is already reported by the GSI, and it's a very good and potential area for us to detail for the detailed investigation again. So if you are interested, this is also available. You can search and you can read it. So I can say that remote sensing is very useful, or ASTER data and hyperspectral data is very useful. From regional scale to narrow down the area is very effective. It matters what kind of methodology you are adopting and how you are interpreting. That matters a lot. And because as on date we have several types of data which are available with us, like your geochemical, geophysical, geological inputs, our field details, our reports are there. If you are integrating all the information together from remote, along with the remote sensing data, and clubbing it and identifying the potential zone is very much important from geological mapping as well as from mineral investigation point of view. So here we are at the end of our lecture session actually. So for if you want to work on ASTER data, there are several websites which are providing ASTER data. Different levels of ASTER data is available. You can explore USGS, Earth data, Globis also you can see, and ASTER data, different level of processing data is available, process data is available. JPL also you can explore. For hyperspectral data, if you are interested for the Hyperion, you go for the USGS or Earth Explorer. Jet Propulsion Laboratory, if you are interested for the NG Averis. NG Averis is the airborne data which was connected with the ISRO, and it's a combined effort of ISRO as well as NASA actually. So certain part of country or certain sites were selected for the data generation of Averis NG. So if you are interested, you can visit this Jet Propulsion Laboratory for Averis NG data, hyperspectral data. More than 400 bands are available here, and similarly you can Jet Propulsion Laboratory Averis NG is available, as well as previous data, old data sets are also available. And in our country, Vedas is also there, which is providing our Averis NG data for the certain location. So not only geology point of view, if you are interested for other work also like soil and forestry also, you can search and you can get the data very easily actually. Prisma is another website you can explore, and you can get the hyperspectral data from there also. Averis NG data, as I told you, like earlier days, Averis data was only available. Averis NG means new generation data, and Averis means it was collected in 80s. So certain areas like here you can see Cuprite or Lunar Lake or low altitude data are available. If you wanted to explore this, you can explore over there. And image processing softwares, there are softwares, some of the paid software, or you have to buy it, like PCI Geomatica or AREDAS or NV or ArcGIS. So processing of hyperspectral data, basically if you are using NV software, so spectral analysis is possible, otherwise difficult for us. And public domain data like GrassGIS, QGIS, Saga. Avyas is the website, your public domain software. You can visit to Veda's site and you can get it downloaded, and you can try to process the hyperspectral data after installation. Every details are given over there, so you can download and you can work on that. You can try hyperspectral data analysis actually. So what kind of trainings we are offering actually? GSI is continuously conducting training programs, not only in remote sensing, but also other fields also, petrology, geoinformatics system, field-based training program. So here in Hyderabad headquarters, we are conducting physical training actually. And if you are interested, there are several training programs, freshers, basic, advanced courses, and sometimes customized and need-based also. So if you are interested, you can approach our GSI. And for the national participants, we have the MOU, especially for the research scholars and working professional PSUs and research scholar. We are conducting training program under ISRO sponsorship, under NRMS program. And every year 3 programs we are conducting for the 3 weeks. If you are interested, please join it and just see the website of GSI actually. One training we are conducting for the digital image processing in GIS for mineral exploration point of view. Next is advanced remote sensing, where we are talking about the hyperspectral processing techniques. And third one is your application of geoinformatics for disaster related studies. So here we are discussing about the landslide, microwave, we are talking about the thermal, we are talking about the glacial, we are talking about the flood. All parameters or geohazards we are conducting. And if you are interested to come here, you can join our program. Not only that, we are conducting several training programs for the international participants also. Every year, twice in a year we are conducting this international program. And online training programs also we are offering. So if you are interested, please visit our website, training GSI TI. So you can visit, and we are offering training programs in remote sensing as well as other fields also. If you are interested, you can register. And in remote sensing, we are offering 2 training programs. One is basics of remote sensing, another is application of remote sensing in mineral exploration. So as on date, if you will see, total 4,500 people are registered for our both the training programs. Every day we are getting the mails, and we are resolving the issues also. And it's a certified program actually. We are giving 30 days to complete one training program. There are lectures, there are series of lectures actually in that. So you can If you are not able to come for the online training program, offline training program, you can come for the online training program, and it is open for everyone. It is not like students cannot join or only research scholars can join. It's open for everyone. Whoever is interested, they can join over there, and after successful completion, you will get the certificate also. And for any contact or any queries there, for regarding this lecture also, so what you can do, you can write to me over these 2 email IDs, and if you want to know about more about the training programs, you can write to our HOD mail, hod.gsiti@gsi.gov.in, or director PGRS _GSITI. You can write over there if you are interested for the more training programs or more training, or you wanted to attend any training program or any customized type of training program, you can contact over here. So thank you very much for your patience sharing, and I hope I am audible to everyone, and if any question is there, you can ask, or otherwise you can write me. 5 minutes only we'll discuss. If any question is there, you can ask. So you can chat it in a chat box. Otherwise you can write me.